been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Geometry 10.6. We're going to be looking at segment lengths and circles. There are 3 theorems here that we're going to study. I did not write out all the words of the theorem, but if you want to grab that from the book, you can, and I'm going to show you what this means in relation to the circle. So the first thing we're going to look at is the segments of chords. So I have 2 chords here, AC and BD, and there's a relationship between these chord lengths or these segment lengths. Remember, if I want to talk about segments being congruent, then I want to write it something like this. And if I want to talk about their distance, then I would write it like this. Remember, this means the distance from A to F, which is a number. So that's the language that I'm going to be using. Remember, if the distances are equal, then the segments are congruent. And if the distances are the same, then the lengths are the same. So what happens here is that we are actually going to multiply the 2 segments that make up a chord, and those are going to be equal to the 2 segments that make up the other chord. So in other words, AF times FC is going to be equal to DF times FB. So AF is this piece right here. That times FC is equal to DF, which is this, times FB, which is that. So the chords intersect at a point, and therefore the chord is then broken up into 2 separate segments, not congruent segments necessarily, but it's broken up into 2 segments. Those 2 segments multiplied are going to be equal to the product of the other 2 segments on the other chord. So again, you need to be able to apply this and solve problems using this equation, and be aware that you may have to solve some quadratics in order to do that. The next theorem is the segments of secants theorem, and so AC, if it was a line, would be a secant. Now, you notice that AC does not go on forever and ever, but AB is a chord, but it really extends out to point C, which is external, that's outside the circle. And so when we have a case like this, we already studied what happens with the arc measures in relation to the angle, but now we're specifically looking at the segments and their lengths and how they compare. So here is what is true here, and that is that CB times CA, so we've got the external part times the entire secant segment, is equal to CD times CF. So again, the external part times the entire secant segment is what is going to be equal here. So you've got products equal to each other, and those products again are the external segment times the entire secant segment. AC is a secant segment. So you know what I'm talking about when I say secant segment. Again, it's essentially a secant that stops at the circle, but in one direction it goes outside the circle. Our last theorem is the segment of secant and tangent. So it's very, very similar to the last one. In the last one, notice they were both intersecting the circle twice. And here I only have one secant segment. So my secant segment is segment BD. And my tangent, of course, segment is AB. And so here is what is true here, and that is that notice for the tangent AB, I don't have anything inside the circle. So what we're going to do is we are going to square that distance, and that is going to be equal to BC, the external segment, times the total BD. So again, it's very similar to the last problem, except that with the tangent, there's not an inside piece, and so we're just going to square the outside piece and set it equal to the product of the other. So those are the 3 theorems, and we'll be applying them in class.
I've been waiting way too long. Yeah.